Okay, plan for the day is to look at absolute value equations, and more specifically, to look at how to solve these absolute value equations. So the first step is, let's review what absolute value means and how to evaluate with an absolute value. So technically, absolute value represents the distance a number is from 0, 0, or from 0 on a number line. Okay? So if I have a number line, and I'm looking at the absolute value of 3, what that means is all points that are 3 units from 0. So there's 0. So 3 units from 0 goes out here to the number 3, and it goes back here to a negative 3. Both of those numbers, 3 and a negative 3, are exactly 3 units away from 0. So if I were to evaluate an absolute value, the absolute value of a positive number does nothing. Okay? How far is a positive 3 from 0? 3 units. However, the absolute value of a negative number becomes positive. How far is a negative 3 from 0? 3 units. Absolute value doesn't care about direction. I don't have to say it's 3 units to the left or 3 units to the right. It's simply 3 units. So the answer to this equation on the left, the absolute value of x equals 3, is asking the question, the absolute value of what number is 3? The answer, 3 or negative 3. Before I go to the next one, the absolute value of what number is equal to 7? Well, the answer would be x equals 7 or negative 7. So really, when I evaluate an absolute value, that expression inside the absolute value could be the number listed or the negative of the number listed. When I evaluate an absolute value, the expression that is inside the absolute value can equal the number or the negative of the number. That is my rule to solve absolute value equations. The absolute value, to solve an absolute value equation, take the expression that is inside the absolute value, and that can either equal the number or it can equal the negative of the number. You see how I did that? Whatever is inside the absolute value, set that equal to the number listed and the negative of the number listed. So when you remove the absolute value and write, you will write 2 separate equations and solve them both. Up here, I didn't have to do that because when I solve that, x could equal 7 or x could equal negative 7. There's nothing really to solve, so I can simply jump down here and write x equals 7 or negative 7. However, in this case, I don't have a single term inside the absolute value. I have an expression. I have x minus 5. So something minus 5 has to equal 7, and something minus 5 has to equal negative 7, just like we said above. All right, solve. Add 5 to both sides. Add 5 to both sides. And x could equal 12, or x could equal negative 2. Take a second and plug that back in. Does that work? If I put 12 back in, 12 minus 5, absolute value equals 7, absolute value, which is 7. Plug a negative 2 in. Negative 2 minus 5 is equal to a negative 7, and the absolute value of a negative 7 is 7. So it does work. a word of caution. Don't simply get this first answer and make it plus and minus. Doesn't work that way. Okay? It did up here, but it doesn't work that way when you have an expression inside. Because what's inside the expression could equal 7 or negative 7, or your number and the negative of the number. However, when I go through the solving process from here to here, I do the same steps, but I do it to a different number, so I'm not going to get both the positive and the negative of a single number. That's a very common mistake. All right, let's get a little messier. Take my expression and split it into 2. Whenever you feel like you've got it, just hit pause, and you take off and solve it and come back and check and see if you got it right. All right, I'm going to take the 3x minus 4, what's inside the expression, and set it equal to the 11. I'm going to take the 3x minus 4 and set it equal to a negative 11. Solve them both. Add 4 to both sides. I get 3x equals 15. Divide by 3, and x is 5. Add 4 to both sides. 3x equals a negative 7. Divide by 3. X equals a negative 7 over 3. When you are done solving an absolute value, you will get 2 expressions, except for one instance, and that's if your expression is set equal to 0, which I'll do one here in a second. All right. Now, what if I don't have an equation that says the absolute value equals something, like I have on the screen? I have 2 times the absolute value of something plus 1 equals 7. I cannot split this into 2 equations right now. My first step is to isolate the absolute value, meaning make it look like this here where it says absolute value equals a number. You have to get it down to that form, or a number equals absolute value. That's fine also. But you must solve or isolate the absolute value. Okay? So my first step, subtract 1. Next step, divide by 2. I do not and never will, as in never, and I never will distribute the number outside the absolute value into the absolute value. Okay? Do not distribute the number outside the absolute value inside the absolute value. You need to get rid of it by dividing it out. And so I end up with x minus 4 absolute value equals 3. Now we are back to what we had before. We have the absolute value isolated, and now we can split it into our 2 parts. X minus 4 can equal 3, and x minus 4 can equal a negative 3. If it's either one of these, the absolute value will make it a positive. Add 4 to both sides, and x equals 7. Add 4 to both sides, and x equals 1. Plug it back in if you'd like to double check. So I'm going to go all the way back to the beginning. 2 times 7 minus 4 plus 1 should equal 7. 7 minus 4 is 3. Absolute value 3 is 3. Notice I did not distribute the 2 into the absolute value. I evaluated the absolute value first. 2 times 3 is 6, plus 1 is equal to 7. Okay? Let's change that. That's not a 7 anymore. That's a 1. 1 minus 4 is a negative 3. The absolute value of a negative 3 is a positive 3. And 2 times 3 is 6. 6 plus 1 is 7. Good habit. Go back, plug it into your original expression, Make sure they both work. If they don't, you did something wrong. Okay? All right, I said I was going to do one like what we'd have, or what you could see if it was not going to be two answers. I have a 0 on the right side. So let's split that into two pieces, right? That's what we said. We said we take whatever's inside the absolute value and set it equal to the positive of the number and set it equal to the negative of the number. However, 0 cannot be positive and negative. It's simply 0. So I don't really have two expressions. I just have one expression or one solution. 2 is the only option. That is the only time you will have just one answer with an absolute value. Otherwise, you get 2. Okay? Let's try another one. Okay, give it a try. Okay, yeah, go ahead, give it a try. Sorry, this comes out to be a mess. Comes out to be a fraction. Didn't mean for it to. All right, here we go. First step, isolate the absolute value. I'm going to subtract 1 from both sides. Divide both sides by -3. Split that into two parts. Solve them both. See how good your fractions are. Add 4 to both sides. So I'm going to add 4 to this. Common denominator makes that 12, which makes that a 20 over 3. Divide both sides by 2. And I get x equals 20 over 3 divided by 2. But to divide by a fraction, I multiply by the reciprocal. Remember, 2 as a fraction is 2 over 1. Final answer, x equals, that reduces down to a 10, that reduces down to a 1, and I get 10/3. I can hear a lot of people already. Am I really expected to do a fraction? There's nothing wrong with fractions. Be comfortable with fractions. All right, next step. Add 4 to both sides, just like before. I have the exact same common denominator. However, my answer becomes a 4/3. Dividing by a fraction is multiplying by the reciprocal. So the second steps should be faster because we just went through and found our common denominator and did all the stuff that we're supposed to do. Did all the thinking of how to deal with those fractions. So now it's just a matter of repeating the same process. So I have my two answers. X equals 10/3, x equals 2/3. All right, we got to try another one. There's some special cases. Solve. All right, first step. Subtract 3 from both sides. At this point, you should see a problem. If you don't see it, I'm going to continue as if there is no problem, but hopefully you see a problem right now. My next step is to split this into the positive and the negative. So most people would do this, and they'd split it into that, and they would split it into that. Oops, that's a positive too. All right, that's my basic process. Oh, sorry, without these. And then I add 5 to both sides. And I divide by 2. And over here I add 5 to both sides. And I add, or sorry, divide by 2. Plug those back in. What happens? So I'm going to take the 3 halves. And I have 2 over 1 times 3 over 2 minus 5 absolute value. Right? I plugged in 3 halves right there. These 2's cancel, and I end up with the absolute value of 3 minus, 3 minus 5. But 3 minus 5 is a negative 2, and I get the absolute value of a negative 2, which is positive 2. We wanted it to be a negative 2. The answer I found didn't work. Why not? Because the absolute value of a number will never be negative. Notice what I have at the beginning. Absolute value of something has to equal a negative 2. That is not possible. Okay? So you should get in the habit of either plugging it back in to check your solution, or before I split them into 2 parts, make sure what the absolute value expression is set equal to is not negative. Okay? All right, that is solving absolute value equations. Give them a try.